All right, this is 9.4, graphing linear functions. Real important lesson as we try to understand how to graph linear functions. So first off, a linear function is one where the graph is a line. A linear function, if you don't have your notes, then take them on paper as always. A linear function is one where the graph is a line. Now, if you guys look at the word linear, you'll see the word line right there. And it should be easy to understand or to remember that linear functions are functions where when you graph it, it's a line. Well, here's what you have to understand. Every point of the line is another set of coordinates, and so that's an x, y pair, right? Another set of coordinates, x, y values that solve the equation. And this is the key concept. So I want to show you an example here. So if you look, I have a line graphed, and I'm only showing you 1, 2, 3, 4, 5 possible points. Before I do anything, I want you to look at the screen. I want you to understand that the line is made up of an infinite number of points. Don't do this in your notes because it'll make them look ugly. But there's a point here, and another point right after it there, and another one right after it there, and a point here, and here, and here, and here, and here. Here, there's a point, 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 another one, another one, another one, another point, another point, another point, another one, another one, another one. Keep going, point, 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 forever that way, point, 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 forever that way. Get it? There's an infinite number of points. And every one of those points have an x value and a y value. They have x, y coordinates. I think it'll go quicker if I erase. They have x, y coordinates, and those x, y coordinates are the values that make the function true or equal. So let me show you what I mean. This first point right down here has coordinates of 0, -3. You guys have it on your notes, right? You can see it there. Hopefully you agree the coordinates of that point are 0, -3, yes? And that's the first point I've listed right here, right? 0, -3. Now, I took this function, and where the y was, I put a parentheses for the y value. You don't need to draw this yet. And where the x is, I put a parentheses for the x value, right? So the y value goes in the green parentheses, and the x value goes in. So we're putting in the y for the y and the x for the x. All right. So let me get rid of this. So on the first one, we're going to put in, I'll use my red first. A 0 goes in for where the x is, right? And a -3 goes in for where the y is. Now, when you solve this, does the left side equal the right side? The left side is a -3. 2 times 0 minus 3, does that equal -3? It does. And that's true. Anytime you put in the x coordinate and the y coordinate of a point into the function, and you end up with the left side equaling the right side, then that point is a point on the line. This is a key concept. Very important. That point is a point on the line. And sure enough, the point 0, -3 is a point on the line. Let's go through and look at another one. All right, I don't know how my line got back there, but let's look at another one. And so we'll go to this one. And hopefully you see the coordinates of that one are 1, -1, right? The second one listed. So let's go through and put those coordinates into the function. So again, the 1 goes in for the x, the -1 goes in for the y. Does the left equal the right? It does, right? You end up with -1 equal -1, true. Again, see, that point is a point on the line. And look, we can go through. I'll do one more. I don't think we're going to do all 5 because it gets boring. But let's do the point 2, 1. So we put 2 in for the x. We put 1 in for the y. And do we get a true equation? We do, because we get 1 equals 1. As long as the left side equals the right side, then we know that it's a point on the line. Now, don't do this in your notes, but let me just, for time's sake, I'm going to not do the next one. Don't cross it out, just leave it. Let's pick another point. How about, let's do this point up here. Do you agree that point's not on the line? So if I put it into the equation shouldn't be true, right? So somebody raise your hand. What are the coordinates of that point? Raise your hand. Tell me the coordinates of that point. Amber?
1, 4.
They are 1, 4. So this time, don't do this in your notes. I'm going to put 1 in for the x and 4 in for the y. Again, don't do this in your notes. It's not part of the equation. Okay? So now when you solve this, you get 4 equals -1. Not true, is it? And it shouldn't be true because guess what? This point's not on the line. But any point on the line does work. Okay? That's the idea, all the points on the line. And even these in-between points, the problem is it's hard to read the coordinates. Look, don't write this, but I could choose this point right here. And it looks to be 2.5, comma 2. I think that's what it is. I'm guessing a little on the 2.5, aren't I? But I think it's 2.5. So let me try it. Don't do this in your notes. 2.5 is the x, and 2 is the y. 2 times 2.5 is 5. 5 minus 3 is 2. Oh, 2 equals 2. I did get it right, but I was guessing that was 2.5. But understand any point on the line. Now look, what if I went to this point? So I'm right up here. I have no clue what the coordinates of that point are. I don't know. It looks like maybe 3.4 and 4.2, but I'm guessing. But you know what? In reality, there are coordinates for that point that exactly, if you put in the x for the x and the y for the y, it would equal. The thing would end up equal. Because here's the point. Every single point on the line, not just the 5 I show you, if you put the x coordinate in for the x and the y coordinate in for the y, it'll make the equation equal. So any point that is a point on the line makes the equation equal or true. Any point that is not on the line doesn't make the equation true. So here you are next year. You're taking you guys doing the Iowa Achievement Test, I think, this year, right? Was it Iowa? You're taking your Iowa Achievement Test. And they give you this. And they say, is the point 7.4 a point on the line? What would you do? You would take the 7, put it in for the x. Take the 4, put it in for the y. You'll end up with 4 equals 14 minus 3, and you end up with 4 equals 11, and you would say, no, it's not a point on the line, because it didn't make the function true. If it did, it's a point on the line. If it doesn't, it's not. Now, I spent a lot of time on that, because this is a key concept. The line are all the points that solve the equation. All right, so that's what we'll say then here next. So C, to verify if a point is a solution, a point on the line. We've done this before, substitute. Substitute in its coordinates to see if they solve the equation. And remember, I mean make the equation true. All right, so do that point, number 1. Do number 1 and do number 2 and see if it's true or false. Is -1, 4 a point on that line? Is 8, -14 a point on that line? Try both. How many got true or yes for the first point? You should have if you put in the -1 for the x and the +4 for the y. You should have 4 equals 4. Okay? Again, remember, always use the parentheses where the variable is. Go ahead and do the second one. Just make sure you get the right number in the right place. Some students like to label X and Y to make sure they don't put them in the wrong place. That's a good tip, by the way, to just keep from making a mistake. So you make sure you get the correct one in the correct place. Well, this last one ends up negative 14 equals negative 2, and that would be a no. That point is not a point on the line. How many got no on that second one? All right, got the concept, so we can verify if a point is part of the solution or not by plugging in the X and Y values. Remember, show the substitution step. Always put a parentheses where the variable is, and away you go. Away you go. All right. To graph a line, you must know at least, all right, so from geometry, any blank points determine a line. What number is that? Anybody know? How many points does it take to determine where a line is located? Brendan? It does take 2, and that is the answer to the question. Once you have 2 points, there's only one place for the line to be. Don't do this in your notes, but look in this clear space right here. If I had 1 point here and 1 point here, then there's only one place for the line to be, and that's right there, right? There's no other way I can draw the line to go through those 2 points. Agreed? I mean, that is it. That is the only way it's going to happen, all right? So that's the idea of the first concept. However, when we do an XY chart, we want to find 3 points and connect those 3 points with a line. And I know some of you are already thinking, Mr. Scarfi, why do we need 3 points, man? Look at this free stuff. You just got done telling us any 2 points determine a line. And they do. So why do we need 3? Anybody know why we want to do 3 instead of 2? Edward?
To be extra sure.
It is to be extra sure. Look, if you only do 2 points and you made a mistake, you'll always see clearly that there's going to be a line. So let me give you an example. Don't write this. I'm just going to use the Cartesian plane as an example. Let's suppose you were coming up with some points, and first you came up with this point. Again, don't write. This is just an example. And let's suppose next you came up with this point. Well, does there exist a line between them? And you would draw the line and think that you're correct. But let's suppose your third point ended up over here. What has to be the conclusion? There's only one possibility of what has just happened. Anybody know? What's the only possibility? Kristen? At least one of your points has to be wrong. Because guess what? They're all supposed to be in a line, right? Because you're doing a linear function, right? You know it's going to be a line. So, hey, I must have made a mistake. So you go back and you recalculate and say, oh, yeah, that one's supposed to be there. Now I'm happy because 3 are in a line. So, again, if you only do 2, you'll never know you made a mistake on one of the points. And therefore, that possibility is there. And so we're always going to do 3. It just takes a second longer, and it's safer. So when you guys graph a line, I want to see 3 points. I want to see a Cartesian plane. Now listen, you always need to show where the x-axis is. Draw it on a line. Be nice if you used a ruler. Draw an x-axis, draw a y-axis. You don't necessarily need the number. But we've already covered this. Remember, each block is 1. The first block to the right is 1. The second block to the right is 2. Third block to the right is 3. First block to the left is -1. Second is -2. Look, if you want to write in the numbers, fine, but you don't have to. And again, first block up is 1, second is 2, etc. First block down is -1, etc. That's the way the Cartesian plane goes, and it's got to be that way. All right, so All we're told is to graph y equals negative 3x plus 5. We're going to use an XY chart. Now, they didn't tell us what values to use for the domain. Oh no. They didn't tell us what to do. And for some of you, that's going to cause you problems because you want to be told everything to do. Well, guess what? We got to use our brain. So let me help you with this. Yesterday, I told you guys that the x is called the independent variable, meaning choose a value for x and we'll figure out which y goes with the x. So here's the thing. We can choose any value we want for x. Now, there's always a wise guy. Yeah. Oh. Mr. Scarfi, let's use 77 for the x. Good. Knock yourself out. I hope you got a lot of tape to tape together the pages of your graph paper to get to 77. All right? But have fun if you want to use the x value of 77. There will be a y value. You'll find out that pair. But that's not the wisest choice, all right, of a number. Because you need a big graph. See, my favorite number is 22. Okay, but again, you got to have 22 spaces on the x-axis. Is that really what you want to do? I don't think so. So if you get to pick the numbers, pick carefully. Now, there's always a best choice first. Out of all the integers, and by the way, you could use fractions, but do we want to use fractions? No, we don't want to use fractions either. They're a pain. You could, but we don't want to. Who would want to use a fraction? So we're going to use integers. So there's definitely a best first one to use all the time. So anybody have an idea? Don't say it. Anybody have an idea? All right, so on 3, you tell me the value to use for x that you think is the best one. Here we go. 1, 2, 3.
5.
Okay, I heard some of it. And so some of you said 0. 0 is definitely always the best first choice. Use 0 for x. Say, Mr. Scarfi, why is that? Here, I'll show you. So again, remember, we're taking the function, and where the x is, we're going to put in that value, right? So I have y equals the negative 3, the parentheses for where the x is, plus 5. And now I'll take my red and I'll put a 0 in for the x. You see how that takes out that whole term? Makes it pretty easy. And what is the y value going to be? 5. So that's why, here I'll go green. So that's why I like to use 0. All right, we have a point. Let's plot it. And I'm going to do my points in, I'll do blue, but you can use any color. So go ahead and plot the point 0.5. Go ahead and plot the point 0.5. Hopefully you went up from on the y-axis up to 5, and that's your first point. Everybody agree? Right there, right? Okay, so again, it's still our choice, independent variable. Again, if you want to be crazy, go ahead and throw in 77, but it's our choice. So who's got a x value next? Luke? -1? Okay. Luke wants to go in the negative realm. We can. -1. It's always 1 in every group. So let's go ahead and sub this in. It is really your choice. So when I sub in -1, Nathan, what do we get? You get 8. Oh no, Mr. Scarfi, I can't graph that. Well, if this was like a quiz, and that's what you had, you're just going to have to extend your axis 2 more, right? That's all you're going to have to do. And your point is -1, 8, right? Right up there. And that's what he did, right? So what else can I do, right? I'll extend my axis and, whoops, that's actually 9, isn't it? Right, that would be 7 and 8 would be right there, so I'm right there. There we go. Always dangerous when you go past the given graph. But that's okay, it's possible. That might happen to you. All right, we're still picking. Somebody else give me a choice for the x value. Allison? 3? Okay, I'd have gone 1, but she wants to go 3. The smaller numbers you use, the closer your points stay together and the easier it is to manage, but that's okay. We can use 3. I would have used 0, 1, and 2. If I were doing the problem, that's what I would have used, 0, 1, and 2. But that's okay. It is your choice. Negative 3 times 3 is 9. Negative 9, 1 second. Negative 9 and 4. Okay, never mind. Just go ahead.
Chloe.
They're all looking at you. So.
I'm sorry. I really need to speak with Fred. I apologize for interrupting. Next, just a moment. Thank you.
Okay, let's back to math. Negative 3 times 3 is negative 9. Negative 9 and 5 is a negative 4, right? And hopefully you agree. All right, so we're at 3 and negative 4. Plot that point. And it's best if you have a straight edge. I'm working on a big tablet, right, and I don't. But if all is right with the world, those things would line up. And if you had a straight edge, hopefully they line up, right? Now, if they didn't, what would you do? Go back and check all 3 of your points. You don't know which one would be wrong. So if they don't line up, you're going to have to go back and check. You don't really know which one would be wrong. By the way, if we would have used 1, I think we would have gotten 2. And if we would have used 2, I think we would have gotten negative 1. Okay? Because again, they'd have to be on the line, yes? If I were doing it, I would have used 0, 1, and 2. Points that are real close together, I always use 0 first. But again, that's fine. We can use negative 1. It's your choice. We can use 3. It's your choice. Just make sure, though, your points are within a line because we're doing linear. Any questions on that one so far? Anybody? Okay. Let's do the next one. All right, notice the only change is, look at the first one, look at the second one. Instead of a y, they used function notation. Not a big deal, right? This should also tell you that the y and the function notation are interchangeable. And they are. F of x or y are exactly the same thing. They are interchangeable. So don't let the notation mess you up. Not a problem. We're going to do the problem the same way. Class, what's the best first value to use?
0.
So let's use that 0. And look, a lot of times when you use 0, you don't even have to write out the thing because it's easy to see that if x is 0, the y is... I hope you're looking here.
1.
If x is 0, y is 1, right? 2 times 0 is 0. 0 plus 1 is 1. And graph the point 0, 1. For a lot of you, I wouldn't advise going past that with the subbing. Besides, you want to show your work. Let's do 1 next. Now, if I were following functional notation, I would put the 1 in for the x, right? We're doing f of 1. But it's the exact same thing. The 1 goes in for where the x is, right? And this time we get 2 plus 1, and we end up with 3. So now we have the point 1, 3. And it looks like we know where our line is going, correct? But again, we're going to do a third point because we want to make sure everything lines up. So again, you can pick anything you want, but I'm going to use 2. I'm just going to do the next one up. And I'm going to do f of 2. That means I put 2 in for the x value. Right? So f of 2 equals, class?
5.
5, right? So go ahead and plot the 0.25. If they all three line up, draw your line. Sometimes students use their calculator cover for a straight edge. Sometimes they take out their credit card. But you do want to try to draw a straight line through them. Okay, like that. Okay, stay with me now. I want everybody to look up at the graph. This looks to be a point on the graph. So let me ask you this. If I input -3 into our function, what would it output? So raise your hand if you think you know. If I input -3 into the function, what would the output be? Raph? I thought your hand was up. Edward?
-5.
How many agree with Edward, -5? Yeah, you're correct because you're looking at the y coordinate, right? Because again, an x of -3 outputs a y of -5. You could try it. 2 times -3 is a -6. -6 plus 1, guess what? -5. And of course that's the case. Hey, if I inputted a -1, what would I output? A -1, right? Because it's that point on the line. All right, one more. Oh no, a fraction. Lo and behold. All right, I want you guys to graph it. Choose your points. Choose them wisely. I would not use 0, 1, and 2 on this one, by the way. I would definitely use 0. I would not use 1. And then I'll let you figure it out from there. All right, see what you can do. Make sure you get a line. Go ahead and graph it. Hopefully with 0. You said, okay, that's 0. Oops, that's not 0. That is -3, right? Because 0 times anything is 0. 3/2 times 0 is 0. 0 minus 3 is -3. I had the point 0, -3. I'll tell you what I would use next. I would use a 2. And here's why. This 2 is like the top of a fraction, right? And do you see how the 2's divide out? And that's easy and the fractions are gone? And 3 minus 3 is 0. I have the 0.20. So guess what point I would use next? Omar? I would use 4. Or if 4 is getting to be too big, I would use -2. Something that divides with that, something that would cause me to reduce that fraction. So watch what happens when you use 4. By the way, did anybody use 0, 2, and 4? Okay, good job. That was good because you did that all on your own. See what happens when you use a 4? Again, remember fractions are reduce before you multiply. So by reducing before you multiply, it's easy. 3 times 2 is 6. 6 minus 3 is 3, and I get the 0.43. And I say to myself, self, are they lined up? And the answer is, certainement. All right, they are lined up. And so I get my straight edge, and I draw a straight line, and I am good to go. Good to go. Good to go. All right, gave you guys some instruction today. Don't pack up. Give me 1 second here of quick review. I reminded you of what your Cartesian plane has to look like. You do need to use graph paper. Remember, linear, the graph is a line. Remember, the xy coordinates of every point on the line make the equation true. If you want to figure out if a point is a solution, put in the x value for x, put in the y value for y, see if you get a true result. If you do, the point is a solution. If not, it's not. Here's the thing. Every point on the line is a solution to the function. So how many solutions are there? If every point on the line is a solution to the function, how many solutions are there? Well, I showed you on this one, 1, 2, 3, 4, 5. 6. We even did that one, 7. I showed you 7 solutions, but how many total solutions are there? How many? Come on, be brave, say it. Infinity, right? Because this is a solution, this point, that point, this one, that one, that one, this point, this point, this point, this point, this one, that one, that one, this, that, this, forever up, forever down, each point, right? Forever in between, every point is a solution. Remember when we graph, how many points do we want to use? 3. What's always the best value to use for the first one? 0, and then be wise in your other 2 choices. All right, that's it. You got your homework. Quiz mañana. Quiz tomorrow.